Hello again, class. This tutorial is going to be about the paired t-test. Now, when would you do the paired t-test versus the two sample t-tests or the pooled t-test? You use the paired t-test when you're doing something before and after, okay? It could be driven by time, it could be driven by location, okay? For example, say we have 10 individuals and we want them to walk every day for a half hour, and we want to see what the results are. So on January 1st, we measure all 10 of them, all right? 1 through 10, all right? We have them walk every day. They all walk every day for a month, and on February 1st, we measure their weight again, all right? We're going to compare walker 1 before and after, and then we're going to look at what the difference is, okay? That's one case. Another case would be if we say we have 10 individuals again, and we want to test to see before and after administering a drug. It could be anything. Let's say that you're administering a cholesterol-lowering drug, and we measure some folks. We measure their cholesterol levels before having the drug administered and afterwards. Okay? And that's when we're pairing up each individual sample before and after. All right? And also you can do it what's considered spatially, or by distance, and different locations, different testers. All right. So what you would do in that case, it's pretty common to test a single sample, but split it up and test it on 2 pieces of equipment that are supposed to be similar, to see if there are any differences in the measurements that come out. And that's the example we're going to be showing. All right, 2 machines are used to measure the tensile strength of a fiber. We want to test to see if the 2 machines yield the same average tensile values. All right, 8 fiber samples are taken. Material from each fiber will be cut and tested on both machines. All right, so just think of 8 fibers cut into 2. A is tested on machine A, B is tested on machine B. All right, so what we have here in this table is we have the data. Machine 1 yielded, for specimen 1, 74. Machine 2 for specimen 1 yielded 78. And then we have a difference here of -4. Specimen 2, machine 1, 76. Machine 2, 79. There's a difference of 3. All right. And what we're doing here is we're subtracting machine 1 minus machine 2 here. And down the column for each specimen. All right? But what we're going to do is we're going to use Minitab. All right? I'm going to show you 2 methods. We're going to use data in columns and also summarized data. All right, so what we did is we input the data here, machine 1 and machine 2, 8 samples here, right here. This is, sample A, sample B for the first fiber. Fiber 2, sample A, sample B. All right. But what we're here is we're going to select the paired t-test. All right. And this dialog window opens up, and we're going to select this radio button here, samples in columns. All right, so we're going to select first sample, machine 1, we click on that, second sample, machine 2, and we click that over. All right, and then this second dialog window opens up, and we're going to put the confidence level in there, okay? So the confidence level here is 1 minus alpha. Alpha is 0.05, so 95 is put in there. All right. Our test mean, we want the mean difference to is 0, okay? And the alternative is that they're not equal. So we put those in there, okay? Now, we can also do summarized data. And from the previous table that we showed you, I took the sample size, I calculated the mean and the standard deviation, and I input those there. Generally, we're not going to have that information, but you have the ability to do it here. And this is the data from Minitab. The top part, that's from the 2-column data input, and this is from the summarized data. All right. There are, a few things we're going to look at again. All right. Our alpha is 0.05. First thing we look at, is the p-value greater than or less than alpha? It is greater than. All right. Is 0 included in this range here? Yes, it is. All right. So what we can say is that we're going to retain the null hypothesis. All right. So we know that 0, meaning no difference in this confidence interval, means that we're 95% confident that there is no difference here. All right? However, if these machines were yours, what would you do? The 0.188, from a statistical standpoint, you would say that we're going to retain the null hypothesis, because 0.188 is larger than 0.05. All right? Now, is that good enough? We only did 8 samples. Is it going to get better? It's going to get worse. So that's the one thing, is that the sample sizes were a little bit low here. So you may want to go back and, this is for an initial test, this is fine. But you may want to go back in and take a larger sample. Another thing that I did in here, but you do not have to do this again, is that I put this in here for a reference. All right. If we had calculated this by hand and we got the 1.46, we would have compared 1.46 to this t-value we got from the table. And what's different about the paired t-test compared to how you look up the t for the pooled or 2 sample is that it's n minus 1, right? So we have 8 samples here, all right, because we're looking at the difference. All right, and the other, using a 2 sample, you actually have n1 plus n2 minus 2, all right? So it's a little bit different here. All right, so here's just one thing to look at. You know that this value needs to be generally in the high 2s for the null hypothesis to be rejected, all right? Just food for thought there, all right? And again, this one here means that when you're looking at the p-value, just remember that if the p-value is above the alpha value is at 0.05, you retain the null hypothesis. If the p-value is below alpha, you reject the null hypothesis. And there's also one last thing to think about, is that, in essence, this right here is saying, what is the likelihood of the null hypothesis being true? All right? And that's it.